All right, we have been talking about last week with matter and the physical properties of matter. So we look at some of the physical properties of matter are boiling point, melting point, color, hardness, magnetism, and viscosity. And so the lab we're working on today is going to dive into what exactly is viscosity. As we open up, print out your lab. Well, actually, you don't have to print it out. But for your lab, the first question says, according to the first page of the lesson, what question are we trying to answer with this lab? So what we're going to be trying to answer in this lab is, first off, what is viscosity? But more importantly, how does temperature affect viscosity? So we look at physical properties, and they're inherent to a substance. So like one of the physical properties is boiling point. So the boiling point of water is 100 degrees Celsius, and it's always 100 degrees Celsius, and it doesn't change. So is that the same with viscosity? Like the viscosity of a substance is permanent and fixed, or does it change with temperature? So that's what we're going to write down here. The question of the lab is, how is viscosity affected by temperature? Okay, so that's the first thing we're going to do. And the second question says, what is the definition of viscosity? So viscosity is a substance's resistance to flow. Does it resist flowing, or does it flow freely? So if it has a high viscosity, that means it resists flowing. It doesn't want to flow. Okay, so we'll write that down. The definition is viscosity is a substance's resistance to flow. Okay, and then the other part of the question is, give an example of a fluid that has high viscosity. So remember, a high viscosity is something that resists flow a lot. So in other words, what's something that's really thick? So think about that. What are things that are thick and they don't flow really well? Well, I like cooking, so the thing I think of is molasses. So let's write that down. Molasses has a high viscosity. And then they give an example of a fluid with low viscosity. What's something that flows really well? Thing that comes to my mind, something that flows really fast, would be water. So water would have low viscosity. Okay, and the third question is, write a hypothesis that predicts how viscosity changes with temperature. Does it change? So is it like the boiling point, which is another physical property? Is it fixed for a certain substance? Does it stay the same, or does it vary? If I think about water, when I look at water, does it matter whether water is at 5 degrees or 10 degrees or 20 degrees or 30 degrees? Doesn't water always flow the same no matter what temperature? So does that mean viscosity is fixed, that it's not affected by temperature? Or is viscosity a little bit different? Is it affected by temperature? That's what we're trying to discover today. Okay, so what you need to do right now is write a hypothesis. So you can say, I predict that the higher the temperature, the viscosity will what? What do you think will happen? Will the viscosity be higher? Meaning, if I have a higher temperature, if the viscosity is higher, that means it flows less. Or if I have a higher temperature, does it flow better, meaning the viscosity goes lower, or is it the same? Okay, so that's what you have to decide. And that's going to be unique to everybody. What do you think? Will it stay the same? Will the viscosity go up, meaning it'll flow less? Will the viscosity go down, meaning it'll flow more? Okay? So we're going to find out. I've got honey at 4 different temperatures, and yes, I know it's not real honey. It's okay. We talked about this in Class Connects. It's honey sauce, but it works. Okay? So I have a honey sauce, and I've got it at 4 different temperatures. This one just came out of the freezer, so it's at -10 degrees. So when you fill out your lab, you need to put these temperatures down because you're going to use my data. I'm not going to have you guys do this on your own. You want to use my data. So we're going to do honey at -10 degrees Celsius. I have some honey in the refrigerator. That's at 8 degrees Celsius. I have some room temperature honey, which is 20 degrees Celsius. And then I've warmed some honey up in a pot over there, and that one's at 50 degrees Celsius. Okay, so those are the 4 temperatures we're going to test. You need to write down the same temperatures. I'm going to put them on this tray, and we are going to measure how quickly each one flows. Nope. I'm going to pull another one out of the freezer. That one's already warmed up too much while I was talking. Okay. So we're going to put all 4 of these on the tray, tip the tray up at the exact same time, and we will find out. Gotta wait a few seconds on that one. How the viscosity is affected by temperature. Need the refrigerator one. Okay, so we're going from coldest to hottest. Alright, here's the one out of the fridge. We're going to put that in the second place. I'm using this one ruler just kind of make sure I keep them all in the same place. Okay, that's the one that's at 8 degrees. This is the one that's room temperature, so that's at 20 degrees. And this is the one I warmed up, so that one's the one that's at 50 degrees. We're going to time how far it travels in 30 seconds. Now we're to the one that was in the freezer. Oh, I already cut it. Okay. So here we go. What was your prediction? Did you think the viscosity would stay the same no matter what the temperature was? Did you think viscosity would increase or decrease? Okay, let's get them all the same starting point. And here we go. I'm going to time them for, oops, just want to move that one. Time them for 30 seconds. On your mark, get set, go! And it's a race, kind of a turtle race. You'll see, even though this one's frozen, it still is flowing. It's moving. We're at 15 seconds. And time. Okay, so now I'm going to get my ruler out and let's measure how far they went. Okay. So this one, the 0 temperature, it went, can you zoom in on this a little bit? It went to here, so there's 2 centimeters. It's right in between 1 and 2, so that's going to be, it went 1.5 centimeters. Okay, the one that was in the refrigerator, you can see it went, oh, that's probably about 2.1 centimeters. We'll write that down. Okay. All right, the one that was room temperature looks like it went about 3.1 centimeters. And the one that was 50 degrees, trying to keep it the line here. Yeah, I know it's not exact science. If I really wanted to be exact, I would have drawn a line at the starting point. Okay. That one is 7 centimeters. So that one went quite a bit farther, but it was a lot warmer. So we'll put 7.00 centimeters. Okay. So once we have our data now, we could see, well, first thing we could see right away that the viscosity of that particular substance did change with the temperature. Make sure your data table has the same numbers. The 1.5, 2.1, 3.1, 7.1. We'll deal with part 2 in just a second, but what we need to graph is just the part 1 data. Okay, so for the part 1 data, they want us to graph it. So first we're going to put in the dots.